Welcome back to Cretitas Math. So today we are going to be looking at slope more in depth. So we've already talked about slope quite a bit. There's two main formulas that you can use in order to find slope. The first being this little delta y. It looks like a little triangle. This means the change in y over the change in x. So that little triangle, that is a shortcut for the word change. So change in y over change in x, that means your vertical change, so how you're changing up or down, over your horizontal change, so how you're changing left or right. This is what we use to talk about kind of the main idea of what slope is, a vertical change over a horizontal change. So we use this mainly when we're looking at graphs and just kind of talking about slope in general. When we're working with coordinates, it's a lot easier to use this definition of slope, which is the same thing, except this is the way that you calculate that change. You take two coordinates, essentially. So we have one coordinate and another coordinate. And the first coordinate gets labeled, well, this is your first x, this is your first y. And then the second coordinate gets labeled, this is your second x, and this is your second y. So that change in y gets calculated by subtracting that first x from the second y, and that will calculate how much it's changed from this point to this point vertically. And then the denominator, x2 minus x1, that's going to calculate how much it has changed from this x1 going to this x2. So you're calculating that change, except this is much easier to use when you're actually just given numbers and a coordinate instead of looking at a graph. But then this one over here is easier to use in a graph since you can kind of just visualize it a lot easier. Okay, so now we're going to look at some examples that I pulled from Desmos. So this is one example that talks about slope. So in this example, it's asking you to adjust the equation so that the line passes through the points. Here you're being given a line. This line is 2x. And you have 2 points in this example. You have one point here that's at the origin, and you have one point here that's at 4, 2. So the easiest way to do this is to kind of visualize the little line that would connect them. And then ask yourself, well, from these 2 points, how much did we go up by? What's that vertical change? The vertical change here is plus 2. And then you would ask yourself, well, what is the horizontal change? So the horizontal change is from here to here. So we're moving this way. That's 1, 2, 3, 4, plus 4. You can use your formula, the change in y over the change in x, or if you can think of it like this, vertical over horizontal, however you think of it. Vertically, we've gone up, so plus by 2. We've gone to the right, which is plus by 4. And then this can get simplified as 1/2 or 0.5. It's much better to keep your slopes in fraction form, since that will be much more convenient once you start working with parallel and perpendicular lines down the road. So if you can tolerate fractions, or even if you're just a little bit uncomfortable with fractions, this is really the time to get used to them, so that will come in handy a lot down the line. Okay, so then this would be changed to y equals 1/2 x. Don't forget that x. The slope itself is the 1/2, and then the y equals rate of change times x. That's the format of the equation of this line. You do have an initial value. Your initial value here is 0, so you don't have to write it if you don't want to. But writing it out is not wrong, it's just a little redundant. Okay, So moving on to the second challenge. So this challenge is very similar. So you want to connect the origin to each of these points with an equation. So the first one here is done for you. It gives you y equals x, so that has a rate of change of 1. And you can kind of see that here, that when you go up by 1, you go across by 1. When you go up by 1, you go across by 1. When you go up by 2, you go across by 2. So your vertical over your horizontal for that line will always give you 1. So now we're going to do line number 1, so using this first dot here. To do that, we're going to just connect these two dots. So we're going to do our vertical and our horizontal. So here we just need to count them. 1, 2, 3, 4, 5. So we're going up by 5 and then count them horizontally. 1, 2, 3. Across by 3. To find that slope is the change in y over the change in x. So vertically we've gone plus 5, horizontally we've gone plus 3. 5 over 3, that's not a fraction that can be reduced any further. So the equation here is y equals 5 over 3x. For number 3, we're connecting the origin to this point over here, which is at 3, 1. So it's the same format. We check how, I'm going to zoom in here, how we've gone up vertically and how we've gone across horizontally. So vertically we've moved up by 1, horizontally we've moved to the right by 3. So this light blue, we're going to have a change in y over a change in x, which is positive 1 vertically over positive 3 horizontally. So this equation here is y equals 1 over 3x, or you can also write this as y equals x over 3. That's another way that you can see it written. Both mean exactly the same thing. Here it's just a fraction multiplication. 1 times x will give you x, and the denominator stays as 3. Okay, number 4, it starts to get a little different. So we're looking at connecting the origin with this point over here at 3, negative 2. Now we're looking at that vertical change and at the horizontal change. So now the vertical change is 1, 2, but since we are going downwards, it's represented by negative 2. We're going to the right, so that is represented by positive 3. So here we have our change in y over our change in x. This becomes negative 2 in the vertical and positive 3 in the horizontal. So the equation here is y equals negative 2/3 times x. I get a different color. We'll use this nice little green. And it's the same thing, so we're going to look at that change in y and the change in x. So going down, we go down by 4 and across by 3. Same process, minus 4 over 3. This equation is y equals negative 4/3 x. And we've got one more. Let's do that one in orange. That's our vertical change, horizontal change. So this one goes down by 6, across by 3. Change in y over change in x. We've got negative 6 over positive 3. This will simplify to negative 2, since negative 6 divided by 3 gives you negative 2. So here the answer is y equals negative 2x. Okay, that was a good example for some slope. Okay, this one here, this is a different Desmos activity, the marble slides activity. So a equation is given, and you need to adjust this blue line in order for it to line up with these stars. So we have a pretty good initial value here. We just want this to look like that. So I'm going to use this as a point, and we want to make this line up. So I would say that the initial value is perfectly fine. We don't need to change that. We just kind of want to tilt this line here so that it tilts downwards. And in order to make a line less steep, so more horizontal, going downwards towards the x-axis, you need to decrease the slope. So here you have a slope of 4. You know the slope is going to have to be less than 4. So if you get something that's not smaller than 4, you know that something went wrong at one point. So we're just going to use the same method that we've been using to connect these two pink dots and find the change in y over the change in x. So here we go up by 2 squares. We go across by 1, 2, 3, 4, 4 squares. So the change in y here is 2. The change in x is 4. We simplify that, we get 1/2 or 0.5. So this equation needs to be rewritten with a slope of 1/2 instead of 4. And that will give the correct answer. Okay, this is another Desmos activity that was landing the plane. So you had to make the linear equation that would connect this plane to the landing zone. So it's the same situation. We have the starting point given to us. The plane is at a point of 0, 15. So you know the initial value is going to be 15. So our y equals blank x plus blank. We know initial value is 15. We need to find that slope. So I would look at, you have this point here, and we want to find another point that's going to kind of line up with it. So looking at this landing zone, there's this kind of dash that's right up on the corner of our graph paper. So this is a good point to use. It's nice and easy to read. And then we can do the same thing that we've been doing. So from this point here, we're going to connect this and now count our squares. So here we have 1, 2, 3, 4, 5, 6. So we've gone down by 6, minus 6, and we've gone across by 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 9. So here the change in y over the change in x, minus 6 over 9. You can always use a calculator to reduce this if you're not very quick at reducing in your head. So here, negative 2 over 3. And that would be the slope. Negative 2 over 3. And that would be the equation to use in this example. Okay, I'm going to skip this one here. So this is another example. Find the slope of the line. So here you'd have to kind of look at the points given. And I'm going to look at this in two ways. So first, I'm going to look at this starting from this point and going towards the other point. So here we go down by 2, across by 1. So our change in y over a change in x, the change in y is -2, the change in x is +1. We get an overall result of -2, and that's the slope. Now, if I was to erase this and look at it from a different perspective, starting at the second point and going towards the other point, will I get the same slope? Okay, so now we're going up by 2. The change in y is +2. But we are going left in the horizontal, which is -1. +2 divided by -1 gives us an overall result of -2. So it doesn't actually matter which direction you look at the slope. The overall result will be the same, whether you start at the first point or at the second point. Okay, and now we have one last example, which is an example with coordinates using that other formula that we saw, y2 minus y1 over x2 minus x1. This is what it would look like. Find the slope of the line that passes through -3, 4 and -5, 5. So we have these 2 points. We're not given a graph, and we don't need a graph in order to find this slope. The only thing we need is to label very, very clearly. So here we have our first coordinate that gets labeled x1, y1. This is the x of my first coordinate. This is the y of my first coordinate. The second coordinate gets labeled x2, y2, x of my second coordinate, y of my second coordinate. And then all you have to do is make sure to put it in the correct spot inside the formula. I'm going to plug everything in now. So y2, that's 5. y1, that's 4. It's important to keep in mind that this negative is part of the formula. Okay, so the negative is not the negatives that are here in your coordinates. These negatives are already a part of the formula. So something that you can do is before you even put the numbers in, you can put the negative there before you even fill those numbers in. So it's kind of like the skeleton of the formula, and whatever the number is, you just plop it in there. So I'm going to do that for the denominator, and you're going to see what happens here. So my x2 is -5, so that gets plopped in the front. And my x1, oops, my x1 is -3. This negative that's already in here, that's part of the formula. So the -3 has to go after. Now I have a double negative. So here we end up with 5 minus 4, we get 1 on the bottom. This is -5 plus 3. Since that double negative turns into a positive. So 1 over -2, which becomes -1/2. So when you have fractions, it's good practice to put the negative sign kind of in the front of the entire fraction or in front of the numerator. It just looks a little bit cleaner, and it's not very common to see a negative on the denominator. So just to keep with standard math notation, either put it up at the front of your fraction or with the numerator. And that is how you find the slope given coordinates. Right? I will see you in the next video.